Well, is it changes when gravity changes, doesn't change with gravity, or momentum does not change in a closed system, which means momentum can only be transferred, it can't be lost. So 3 is going to match up with A. And then you have weight and inertia. So weight, remember, is basically the force of gravity, or it's the acceleration due to gravity times your mass. So if you go to an area when gravity changes, your weight is going to change. So would weight change when gravity changes? Yes. Doesn't change when gravity or with gravity? Well, that would be inertia. The main thing with inertia is the mass. And so your mass is not going to change with gravity. Your mass would stay the same on the moon. Your weight, on the other hand, it does change with gravity. So if you go to the moon, where the moon's gravity is about 1.6, you're going to be lighter. The next portion, if you're going down, you're just matching up Newton's 3 laws of motion. The first one says for every action, there's an equal and opposite reaction force. This is telling us Newton's 3rd law. Objects at rest stay at rest. Uno, 1st law, unless acted upon by an outside force. And force equals mass times acceleration. It's a fancy way of just saying our formula, which is Newton's 2nd law. Then you'll head over here to the right side. Which of Newton's 3 laws applies? A rocket moves forward because gases are pushed out the back. Well, gases are going out the back, but the rocket is going forward. Action, reaction, that would be Newton's 3rd law. More force creates more acceleration. Well, if you look at the force formula and you increase that force number, it would increase your acceleration, because acceleration is force divided by mass. So if you increase your force, therefore your acceleration would also increase. A magician pulls out a tablecloth out from underneath plates, and the plates stay put. Well, the plates are an object that is not in motion, and they want to stay not in motion, and they want to stay at rest. So that is Newton's 1st law. You pull back on the paddle, and the canoe goes forward. 3rd law, action, reaction. A larger car takes a bigger engine to move it. Well, that larger car would indicate that you have a larger mass. Anytime that you're dealing with mass or acceleration or force and you're trying to figure out what happens when you raise one or lower one, that's going to be Newton's 2nd law. Once the engine stops, a rocket coasts through space. Well, that rocket is in motion. Even when the engines stop, it's going to stay in motion unless some other force is acting on it to slow it down, maybe some sort of friction. But if it's out in space, it's just going to keep going. But that would be Newton's 1st law. Then let's move down the paper. Find the momentum of a 25 kilogram object going 4 meters per second. Well, momentum is mass times velocity, so 25 times 4. And then your units would be kgms, or kilogram meter per second. 25 times 4, 4 quarters equals $1, so 25 times 4 would be 100. An object is going 22 meters per second and is 3 kilograms. Find the momentum. Same rules apply here. Mass, so 3 kilograms, times velocity, 22. 22 times 3, figure out what that is, and then you would have your units be kgms, or kilogram meter per second. Next up, you got a ping pong ball. Ping pong ball has 2 kilogram meter per second of momentum. When it's thrown with a velocity of 8 meters per second, we are tasked with finding the mass. Well, if you use your triangle, cover up the M on the triangle, you would have momentum on top and you would have velocity on the bottom. So you go 2 divided by 8. So it's going to be a pretty small number. And then if you're doing mass, your answer would be in kilograms. So 2 divided by 8, figure out what that is, and then put kilograms as your unit. The last one here on the left, 25 kilogram cart, momentum 125. How fast is it going? When it's asking how fast, it's looking for a velocity. Velocity would be momentum, 125, divided by your mass. So 125 divided by 25, and your answer would be in meters per second. Back over here on the right side, it says draw a free body diagram to show a scenario where a car, or any object, you could draw a little car here, you could draw a box, you could draw a circle, whatever you want to do there. But whatever that object that you draw is, it is accelerating. So remember to use 4 force arrows, have 1 arrow for thrust, friction, weight, and normal. Remember, thrust is what's propelling you forward, friction is opposing that motion, and weight is going down, while the normal force is perpendicular to whatever surface you are on, so it's going to be going up. So just draw a car there with 4 arrows and make sure one of your arrows, particularly if you're accelerating, should be the thrust arrow. That should be the greatest. So have your thrust arrow be the greatest. Make sure you label it. So just on that arrow, label it the thrust one, or put a T on there for thrust, F for friction, W for weight, N for normal. Down here, find the weight of a 25 kilogram table. You could either put your answer in newtons or pounds. It's up to you. Newtons is obviously easier. There's one more step to get it into pounds. But 25 times, what would you multiply by? Well, if you're solving for weight, you got to multiply by the acceleration due to gravity. We're assuming this table is here on Earth, and the gravity is 9.81. So 25 times 9.81 will get you your number in newtons. You can leave it at that. If you want to convert it to pounds, divide by 4.448. And the last one here on the bottom right, a 20 Newton force pulls to the right, and friction pulls with 5 newtons to the left. If the mass is 5 kilograms, find the acceleration. My hint down at the bottom says figure out what the net force is first, then use the formula force divided by mass equals acceleration. Well, the net force, if you're pulling with 20 newtons of force to the right, and friction's pulling with 5 newtons, it doesn't say what direction friction is, but we know friction opposes the motion. So if we're pulling to the right, friction's going to oppose it to the left. And so what is our net force? Well, if you got 20 to the right, 5 going to the left, overall you would have 15 newtons to the right. So your net force would be 15 newtons. Then you divide that by your mass, which is 5. 15 divided by 5, what is that? Some of you might know it in your head, and then you would, since you're solving for acceleration, your answer would be in meters per second squared. And that is it.